Well, hello. All right, so for 9H, so this is the second day of quadratics. So this is focusing on various general applications that you could potentially see. So these are the questions that people ask me all the time. When the heck am I going to be using this? These are like the abstract, out there, outlandish kind of applications, but it still applies what we've been learning. So just to kind of list out the different ways that we've been solving these quadratic equations. So in 9A, we did factoring, also looking at tables. 9B, we focused, nope. 9A focused on graphing and tables, whereas 9B focused on factoring. And then we looked at 9E and 9F, which focused on computing the square and the quadratic formula, respectively. So we're going to be using just a variation of all these different methods of solving. There's not going to be a specific one that we have to use for a specific one. If you're very adept at using, say, completing the square, focus on just completing the square. If you really like using quadratic formula, then focus on using quadratic formula. That's the beauty of the application questions here, is there's no one right way to do it. So you can use any method that you please to actually solve these questions. So starting off, so the base of a triangle is 3 inches less than its height. The area of the triangle is 9 square inches, and we want to find the height of the triangle. So I went ahead and I drew a triangle, and we're going to go ahead and label. So the base is 3 inches less than its height. So the base is going to be the height minus 3, whereas the height is just going to be h. All right, and then we know that the area, based on the given information, is going to be 9 square inches. So we want to actually find the height of this triangle. All right, so let's start off with some general information here. So the area of a triangle is going to be 1/2 base times the height, or base times height divided by 2, whichever formulation you prefer, it's all the same. Personally, I like to keep it separate so that I can distinguish the 1/2, the base, and the height in separate little areas. All right, so I'm going to plug everything into the formula and its little respective location. So I know the height is 9, then times 1/2. The base is going to be h minus 3. And then we just have the height that we want to solve for. So this is what we're really going to be solving. So kind of going back to what I said earlier, you can use any method. There's not one correct way. But however, I will say, no matter what you're going to do, you have to put the equation in standard form. So that's where you have to start. So my thing here is I want to go ahead and just get rid of this 1/2. I don't want to deal with the fractions at all. I just want to get rid of them from the get-go. So what I'm going to do, since it's dividing by 2, I'm going to do the opposite and multiply both sides by 2, just so I can get rid of that 1/2. Because I know you guys hate fractions. They're the plague. You just want them gone. So 2 times 9, it's going to give you 18. And then on the right side, the 1/2 and the 2 are going to simplify. So those are going to be gone. So then we're going to have h minus 3 times h. All right, next thing is I want to distribute the h over here to everything inside the parentheses. So that's going to give us 18 equals h squared minus 3h. And now to put it in standard form, I want to get rid of that 18. So in order to get rid of it, what I'm going to do is I want to subtract it on both sides. So I'm going to have h squared minus 3, that's a 3, 3h minus 18 equals 0. So now that our equation's in standard form, now you can kind of pick and choose which method of solving you want to do. So if you want to do factoring, you can. If you want to do completing the square, you can. If you want to do quadratic formula, you can. So just remember, factoring is only going to work if the equation itself is factorable. Now, if you don't care about which method you do, if you want to use just one method for all questions be done, I would recommend using the quadratic formula. But in this case, I'm going to do this one by factoring just to kind of give us a variation and use different things to solve. So I'm going to copy and paste this equation up here. So I'm going to solve by factoring, which involves factoring by grouping. So you need to do your A, B, C's. So A is 1, B is -3, C is -18. So I want to do A times C. So 1 times -18, which is -18. So I need to find factors of -18. So I have 1 and 18, 2 and 9, 3 and 6. So I need these to add up to a -3 somehow. So remember, they multiply to a negative, and the B value is negative, which means your bigger value is going to be a negative. So in order to get them to add up to a -3, no wait, nope, I got that backwards. How dare I? Your B term is negative, your bigger factor matches the B term. So the bigger ones are negative, which means the smaller ones are positive, which means our factors are going to be +3 and -6. That's what we're going to use to split the middle. So if I add those together, that's a highlighter. So if I add those together, we get -3. So that's what I'm going to use over here. So I'm going to have h squared minus 6h plus 3h minus 18 equal to 0. So now I'm going to do grouping. So I'm going to group the first two terms together and then group the last two terms together. So out of the first group, so this first group here, the h squared minus 6h, I'm going to factor out an each. So when I do that, I have h minus 6 left. And over here, in the second group, I can factor out a 3. So when I factor out that 3, we're going to have h minus 6 left. So remember, your polynomials or your binomials here in the parentheses must be the same. So since they're the same, I can go ahead and factor out that h minus 6. So h minus 6, factor it out, which means these are gone. And what I have left is h plus 3. Okay, so I want to be able to solve this quadratic equation. So now that I have it in factored form, the next step is I actually want to take both of these equations, or both of these factors, rather, and I'm going to set each one of those equal to 0. And I want to set them, nope, and then I want to solve them. So over here, what I'm going to do, I'm going to add 6 over here. So I have h equals 6, and subtract 3 over here. So I have h equals -3. All right, so I want you guys to think about this for a second. Think about the validity of these solutions. Think about what these solutions are telling you. We're looking for the height. So this is over here is saying it will work if you have a height of 6, but it will also work if you have a height of -3. What's wrong with that picture? Can you actually have a negative height? No, you cannot. So this solution, the h equals -3, is what we call extraneous. It's a false solution. It's like getting a false positive. I have no idea if I spelled that right. I hope I did. I'm going to make sure. I did. Okay. So the solution is called extraneous. It's essentially a false positive. It's saying, hey, this is a solution, but in actuality, it's not. All right. So that means h equals 6. That is going to be our height. So keep in mind, these are applications. If I give you words, I expect words in return. All right. So the height of the triangle is 6, whatever the units were. Is it inches? Yes. All right, so there's the height. So that was solving by factoring. All right, so now moving on to the second one here. So the length of a rectangle is 6 inches more than its width. The area of the rectangle is 91 square inches, and we want to find the dimensions of the rectangle. All right, so I went ahead and drew a rectangle already. So the length of the rectangle is 6 more. So I'm going to go over here. So the length is 6 more than the width, and the width is just the width. And we have an area, did it say 91? Yes, it did, of 91 square inches. All right. So just some kind of general background knowledge. If you can remember, the area of a rectangle is equal to the length times the width. Now kind of think, what's the ultimate question here? What do we want to know? So they want to find the dimensions of the rectangle. So when I say dimensions, that's saying find the length and the width. All right, so I'm going to fill in those missing gaps. So we have 91 equals the length. Nope, I'm getting this wrong. Is the length, which is W plus 6, all times W. So to start solving this, you have to put it in standard form regardless of which method you're using. So I'm going to distribute that W. So we're going to have 91 equals W squared plus 6W. So over here, now I'm going to subtract the 91 so I can put it in standard form. So we're going to have W squared plus 6W minus 91 equals 0. So once again, it doesn't matter if you do factoring, quadratic formula, completing the square, it doesn't matter. So just to kind of give you some variety, I'm going to do this one by completing the square, just to kind of try to appease as many people as possible. All right, so with completing the square, your A value has to be 1, which in this case it already is. Then the next step is move over the 91, or your C value, which is 91. So W squared plus 6W. And add the box, plus 91 plus the box. Wow, those boxes do not match, but it is okay. Close enough. All right, so for completing the square, you're going to do B divided by 2 and square it. So your B value is your 6 over here, that positive 6. All right, so I'm going to have 6 divided by 2 all squared. 6 divided by 2 all squared. So that's going to give you 3 squared, which is 9. So 9 is what I'm going to add in both of these boxes. All right, so now on the left side, now I want to factor. So remember, for completing the square, the left side should always be a perfect square trinomial. So when you factor square root of the first, square root of the last, and keep the sign of the B. So square root of the first is W, keeping the sign of this B, which is addition, and then square root of the last, which is 3 squared. And that's going to equal 91 plus 9, which is going to give you 100. All right, so now I want to solve this equation for W. So in order to do that, I'm going to take the square root of both sides. So I'm going to have W plus 3 equals plus or minus the square root of 100, which is 10. Then I'm going to move over that 3. I'm going to put it in front. So we're going to have W equals negative 3 plus or minus 10. All right, so now I want to be able to find both of those solutions. So I'm going to do both plus and minus. So negative 3 minus 10, but also negative 3 plus 10. All right, so when I do minus, I get negative 13. And when I do addition, that gives me positive 7. So remember, we can't have a negative measurement, which means this W equals 13 is extraneous. I cannot use it. This is my false positive. All right, so which means my width is going to be 7 inches or feet. I don't remember, inches. All right, so now if I know W is equal to 7, then that implies that the length is going to be equal to the width plus 6, I believe. Yep, according to the initial problem, which is going to be 7 plus 6, which is equal to 13 inches. All right, so my dimensions are 7 by 13 inches. So you could say the length is 13 inches and the width is 7 inches. That is okay as well. As long as you're stating the fact that the dimensions are 7 by 13 or 13 by 17, it doesn't matter. However, what will matter is if you say the width is 13 and the width, or no, and the length is 7, because then you're getting it backwards. So just be careful about that. Because according to the actual problem itself, the width specific, or the length specifically, is longer than the width. All right, so we did a factoring, then we did a completing the square. So I think this last one over here, not last one, but this one uses a quadratic formula, so that works out perfectly. All right, so a decorative arch which spans a bridge is modeled by the equation y equals -1/4 x squared plus 12x, where y is the height of the arch in feet and x is the distance from one edge to the bridge in feet. So part A is asking what's the maximum height of the actual arch itself. So here I have the arch drawn on a graph and using the equation modeled. So I want to find what's the maximum height of the arch. So keep in mind what that's asking for is I want to find this point right here. I want to find this value. This is part A. If you haven't figured it out, I actually like doing these drawings. I'm a very visual person, so I like having drawings as kind of a supplement. All right, so in order to find that value, what we're going to have to do is actually find the AOS. So right here, I'm going to go ahead and draw my AOS. It's approximate. So to start off, I want to find my equation values. So I need to find my A, my B, and my C values before I can actually do my AOS. All right, so looking back at your equation over here, we have an A value of -1/4. Then we have a B value of +12. And we don't actually have a C value, so what that means is we have a C value of 0. So to start off, we're going to find that AOS, so the opposite of B over 2A. All right, so the opposite of B is going to be -12 over 2 times -1/4. All right, so we're going to have -12 over 2 times -1/4. So think about it in terms of quarters. If you have 25 cents and you double it, you get 50 cents. But 50 cents is only half of a dollar. All right, and then when you do -12 divided by -1/2, that's the same as multiplying by 2, which is going to be 24. All right, so the x value represents distance. So the midpoint right here is going to be 24, 0. So that's our midpoint. So over here, this is the origin, 0, 0. And then we know this is going to be 24, something. So now we got to find the actual height. All right, so over here, now I'm going to plug in that 24. So -1/4 times 24 squared plus 12 times 24. All right, so let's go ahead and bring up that Casio. I clicked on the wrong button, of course I did. And now we wait, because I'm a dum-dum who clicked on the wrong thing. Okie dokie. All right, so to find this value, we gotta go to the run matrix, so execute. All right, so -1/4 parentheses 24 squared, then plus 12 times 24. And that's going to give you a maximum height of 144. I clicked on the wrong thing. You could ignore everything you see here. In fact, I hope you do. There we go. All right, so when you click on this, or not click on this, when you get your value, you get a maximum height of 144 in terms of feet. Oh, well, I gave you words. I want words in return. So just to put it in perspective, this is now 144. So the bridge, or the arch, has a maximum height of 144 feet. So literally just one sentence. I'm not looking for a whole essay. I don't want to read a whole essay. I just want a sentence. All right, and part B is it wants to look for what's the length of the bridge. So what this is really asking for, length of the bridge, is what is the roots? Actually, that should be what are the roots. It's fine. I don't teach English. I really don't teach English. Forgot my punctuation. All right, so we're really looking for this point over here. So we want to know what is that coordinate going to be. So we know it's going to start at 0, so we don't have to worry about subtracting the roots. No. All right, so keep in mind, you can actually use logic for this one. You don't actually have to use quadratic formula. This is where logic and critical thinking really come into play. So think of it this way. Look at your drawing, or mine, whichever one. If you know this is your axis of symmetry, and you know this is a midpoint, if it's halfway there, you could easily double your point here to get to the maximum point here. So if I double 24, you get 48. Because remember, it's the axis of symmetry. It should be the same on the left and on the right. All right, so if I know it goes from 0 to 48, then I know the bridge is 48 feet long, or the arch. So I'll just put a little disclaimer down here. So double the AOS. All right. Now, if you wanted to do quadratic formula, you can, but if you want to, you can. You go for it. But I'm also sure you guys would want to limit the amount of math you actually have to do. Okay, so that kind of works out, even though we didn't do quadratic formula. Quadratic formula is the way that you would solve that one. All right, so now down here, we're going to look at consecutive integers. So whenever we talk about consecutive integers, it's like, yeah, duh. But when we put it in math and writing it in terms of math, that's when it starts getting a little ambiguous and people start getting confused. So when I say consecutive integers, consecutive just means the next one. It just means the next. So if I'm talking about 4, or here, let's actually do this. 3, 4, 5, 6, 7, 8, 9, and 10. That should be plenty. All right, so let's say we're talking about 4. Well, the consecutive integer is 5. Then now we also have what we call consecutive even and odd integers. So if I'm looking at consecutive even integers, that means the next even integer. So if I'm looking at 4, then consecutive even would be 6. I'm not taking 5 because that's odd. I only want the consecutive evens. That'd be 6. So it'd be so on and so on. So if I'm looking at the consecutive even from 6, then we're looking at 8. If I'm looking at consecutive even from 8, then we're looking at 10. But the same idea works for consecutive odds as well. So if I start at 3, consecutive odd would be 5. If I start at 5, consecutive odd would be 7. If I start at 7, consecutive odd would be 9, so on and so on. So we could be talking about consecutive integers, which would mean the number right next to it, so on and so on. Or we could be talking about consecutive even or odd, which means we'd actually have to skip a value. Okay. So now we want to write it in terms of math. So if I'm looking at consecutive integers, the first digit itself would be just the variable x. But the next one, the consecutive integer, would be represented by x plus 1. I'm going to the next value. So let's say my starting value is 4. If I want the consecutive integer to 4, well, that's 5. But how do you get to 5? Well, you literally just add 1. So that's where the x and x plus 1 are coming into play. Okay. So the same idea kind of works if we're doing consecutive even or odd. But consecutive even or odd, oh, that should be a plus 2. That should not be a plus 1. Consecutive even or odd, so you're starting with the value x and you want to skip 1, so that means you have to add 2. So kind of going back up here. So let's say I'm starting with a consecutive value of, or I want to start with 6. Now I want a consecutive even value. So if I'm starting with 6, the consecutive even value is 8. But to get from 6 to 8, you have to add 2, which means plus 2, it's going to be 8. So that's where the x and x plus 2 come from. And then the same idea is going to work with, let's see if this works. Nope. I'm determined to make this work somehow. All right, let's try this. Nope. I think I got the 8 on that one. Nope. All right. So same thing works for odds. So if I'm starting at 3, I want to add 2 to get to 5. If I want to start at 5, I want to add 2 to get to 7. If I'm starting at 7, I want to add 2 to get to 9. So you have to add 2. We're skipping that value. So that's where that plus 2 comes from. All right. And then just if we have more than one consecutive integer in general, so we could do the first value is just x, the next consecutive is plus 1, and then the next consecutive would be plus 2. So, and then the pattern just continues. So if we want the third consecutive, it'd be x plus 3, fourth consecutive would be x plus 4, and so on and so on. All right, so we have some applications dealing with consecutive values. So the number 4, we have the product of 2 consecutive odd integers is 1 less than 4 times their sum. So we want to find the 2 integers. So keep in mind here, the problem itself doesn't state whether we have to have the negative values or the positive values. So we can have more than one. So it wants the product of 2 consecutive odd. So consecutive odd means that we're going to be using x and x plus 2. But now keep in mind we're doing the product, which means we're actually going to be multiplying these. So I'm actually going to rewrite this as x times x plus 2. We're going to be multiplying those together. All right, and it is, so is an indicator that we're looking at equals, and we want 4, nope, can't read, it's fine. 1 less than 4 times their sum. So I want 4 times their sum, and then I want to subtract 1. So I'm going to add that first and the consecutive odd together. So x plus 2. So I'm going to add them together, multiply it by 4, and then subtract 1. And I want to find those integers. So that's going to be my equation right there. All right, so first I'm actually going to identify my variables. So x is my first integer. And then x plus 2 is actually my second integer. All right, so I know the product of both of those integers is going to be equal to 4 times their sum, so x plus 2, then subtracting 1. So this is the equation that we're solving. All right, so no matter what method you're going to use, you have to convert it to standard form. So there's a lot of distributing and combining like terms that's going to be happening. So over on the left side, I'm going to go ahead and distribute, whereas on the right side, I want to combine like terms first. So x squared plus 2x equals 4 parentheses, 2x plus 2 minus 1. So now over here on the right side, now I'm going to distribute. So I'm going to have x squared plus 2x equals 8x plus 8 minus 1. Now I want to combine like terms over here on the right side. So x squared plus 2x equals 8x plus 7. All right, so now we need to move everything on this side over here to this side, to the left, so I can put it in standard form. So what I'm going to do first is subtract 8x. So I'm going to have x squared minus 6x equals 7. And now I need to move over that 7. So I'm going to have x squared minus 6x minus 7 equals 0. And now that I have it in standard form, now you can kind of pick and choose which method of solving you want to do. So whether you want to do factoring, whether you want to do completing the square, quadratic formula, or whatever. So because the last one we kind of cheated our way out of quadratic formula, then I'll go ahead and do that one. All right, so my A value is 1, B value is -6, and C value is -7. So just for frame of reference, I'm going to go ahead and write out quadratic formula, just in case. So opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. All right. Also, if I haven't mentioned it before, a good way to memorize quadratic formula is if you kind of sing it along to Pop Goes the Weasel. There's actually a song that goes to it. All right, so I'm going to plug in those values. So we want the opposite of B, so we want +6 over, nope, +6 plus or minus the square root of B squared. So I want -6 squared minus 4 times your A value times your C value all times 2, or divided by 2 times your a value. Okay. So I'm going to go ahead and just use the Casio for this one, just to kind of streamline and make this process go a little bit quicker. So open up a fraction. So 6 plus square root -6, put it in parentheses, squared minus 4 times your a value times your c value, which is -7, all over 2 times your a value, which is 1, which you don't actually have to plug in. All right, so we're going to get x value of 7. And now remember, we got to account for the subtraction sign as well. So I'm going to go back and change this to a subtraction. Excuse me. And then we have an x value of -1. So these are our two x values. Now remember, we want the consecutive odd integers. So if those are both the x values, then that means x plus 2 would be 9, and x plus 2 here would be +1. So we have two sets. Now keep in mind, I could ask for just the positive set, or I could ask for the negative set. So because I didn't specify which set, you have to give both. So the consecutive odd numbers are, I'll start with the smaller one. So x equals -1 and +1, and x equals 7 and 9. So if I just wanted the positive set, then you would totally disregard the -1 and 1. If I wanted the negative set or the smaller set, then you would disregard the 7 and 9. But in this case, I wanted both. So keep in mind, if you solve this by factoring, completing the square, or whatever, no matter which method you use, you should get the same answer. Should. All right. So there's number 4. So now we're going to do number 5. So the product of two consecutive integers is 16 more than the first. I'm going to find the 2. All right, so it doesn't specify if we're doing consecutive even or odd. It's just consecutive integers, which means it's going to be x and x plus 1. So we're doing the product of two consecutive integers. So that's going to be x and x plus 1. All right. And then once again, we're going to go through each of these words and find out what their math equivalent is. So is going to be equals. And then 16 more than the first. Well, the first number is just x. So it's going to be x plus 16. And then we want to find the two integers. So up here where I did x is the first integer and x plus 2 is the second, I'm literally just going to copy that down here. The only change you have to do is instead of x plus 2, it's going to be x plus 1. It's the only difference. All right, so now I'm going to go ahead and set up and solve. So x times x plus 1 is equal to x plus 16. All right, so remember, you have to convert to standard form no matter which method you're using. It doesn't matter which one you choose. So first thing I'm going to do is distribute. So when you distribute, you're going to have x squared plus x equals x plus 16. All right, I'm going to subtract x on both sides. And if you notice, those are going to completely zero out. So we have x squared equals 16. So I don't actually have to even use quadratics on this one. I could actually just use solving equations. Because if I take the square root of both sides, 16 is a perfect square, which means x is going to be equal to plus or minus 4. All right, so I'm going to split this so that we have our two different solutions. So we have x equals negative 4, but we also have x equals positive 4. So I need to find the consecutive integer. So I'm going to do plus 1, which is negative 3, and plus 1, which is 5. So we have negative 4 and negative 3, and 4 and 5. That would satisfy both of these values, or the scenario here. So the consecutive integers let's start with the smaller one first. So x equals negative 4 and negative 3, and x equals 4 and 5. So these are the consecutive integers.